Hello and welcome to my vlog. This is another episode on automation with Make. Last time I talked about Make's API and how it allows you to manage your scenarios from within your code. I talked you through a simple implementation where I created a server, exposing a few endpoints, allowing you to create or update a scenario or set module data or fetch the scenario blueprint. And I demonstrated how you can use this API, so you can check my last video or my previous video. But today I want to talk about a slightly different approach because, as you can see, using this request response model has its disadvantages. So first of all, when I want to submit complicated data, structured data or complex objects such as blueprints, I need to worry about correct escaping. All of this needs to be correctly escaped, otherwise I won't be able to send it. I can't really control formatting, so I could format it nicely, but I would have to do it outside of this Postman interface and then paste it. And more importantly, I can't really chain operations. So for example, when I create a scenario and it's a success, that's great. But what if I immediately want to, say, fetch the scenario's blueprint? Then I would again have to manually copy the new scenario's ID and paste it into this endpoint so that I get the blueprint. So the drawbacks, that's obvious. And today I just wanted to show you how you can address them. So this is the server approach to changing or managing your scenarios in Make. And today I will talk you through about the client approach. So I created two different flavors of clients. One is implemented in Java and the other one is in Kotlin. Most of it I'll explain using the Java client, because I just assume that most of you guys watching this vlog are more proficient with Java, or use Java in your daily job. The language of my preference is Kotlin because it's more powerful and more concise compared to Java, but I assume that just the Java community is bigger, so that's that. Alright, so first things first, what I'm going to need is I'll need an API token. So if I log into Make, I go to my API section, and as you can see, I've already created a token. For working with scenarios, it just needs two scopes, read and write, on the scenario object. So I can no longer see the full value of the token, but you will see shortly in my code. Alright, so that's one thing. And the other thing is, notice the zone. So my organization is created in the EU zone. So there are two regions I can choose from, either US or EU region. I'm based in the EU, so I'll be using the EU region for making requests to Make. Alright, so let me just go to my code. So first of all, the blueprint. We're going to create a scenario, and as you can see right from the start, there's this huge benefit of being able to work with local files. I've created this blueprint JSON. I just downloaded it from my Make scenario. It's not an empty blueprint. It actually does something. It parses JSON and processes the data. So there are a few modules there. The original scenario is called parse.json scenario. In fact, I can show you in the browser. This is, if I go to the scenario section, experiments. This is the folder we will be working with in this tutorial. And the scenario I'm talking about is this one. So it has two routers, bunch of JSON processors, and it's all chained together to do stuff. What exactly does it do is not as important as that there are modules we can have a look at. All right. So, and basically what I want to do, I want to create a copy of the scenario from within my code. So if I go to, I've created a brief template where I prepared all I need. So first of all, this is my API token. Obviously, I will delete it after having recorded this video, but that's the token that allows me to work with scenarios. These are coordinates of where the new scenarios will be created. So that's my team ID and my folder ID. So again, back to the browser. This is the folder ID, for example, and that's the team ID here. All right, so there's that. And then instead of passing blueprint as string or the actual content, I just declare that there is a file called blueprint.json, which is this file here. Let me just amend it. I just say copy so we can easily distinguish between the original and the newly created scenario. And that's that. All right, so first thing I need to do, I've got my main class and main method. So those of you who are familiar with Java, you know that I can run this piece of code and it will execute everything that's inside the main method. So first thing I need to do is I want to create a new instance of my client. So I've created a factory for that. Factory pattern is a common pattern in software engineering where you just instantiate new objects. This is the way how to instantiate new objects. So let me just create a variable for this. I'll call it make client. So what I've just done is I'm saying, using this token, please create a new instance of the make client in the EU region. So make client is the piece of code that allows me to communicate with make and make changes to my scenarios. So now I have an instance of the client, and I said I wanted to create a new scenario out of the blueprints file stored in my local file system. So what I can do here is I can call make client, create scenario, and then I can simply pass the team ID, the folder ID, and ultimately the blueprint path. Right, so this call here will create a new scenario. The only thing I need to do at the end, I just need to trigger the operation. So I need to say get or throw, or get or null. So internally, this create scenario, it's an asynchronous operation. Internally, it uses construct in Java called complete of the future. And complete of the future is like a template. You can outline all the operations you wish to make, but at the end you need to ultimately trigger the processing. So you need to trigger the processing, and then at the end of it, you will get some kind of results, either success, in which case, if it's successful, I will get a new scenario, or if it's a failure, it'll throw an exception. So let's test that. So if I run this code, compiling, now running, and alright, so it seems to have been successful. There is no output because I did not print any output. If I go to my browser and refresh the page, well, I got the copy of the parse.json scenario. Alright, so that's not too surprising. Let me just delete it so that it's not in the way. No, that's cool, but that's not any better as compared to just submitting this create scenario request. Well, actually it is better because this time I can review and craft the JSON by hand, which is nice. But not much beyond that. I can do much better. So first of all, I can log in in case the operation succeeds. What I'll get a scenario object, and I can print it out, for example, using my logger. So I can say info and say successfully created a scenario, and then I can just print it. Equally, if the processing fails, I can log a failure. I can say, well, here is an exception, and I can say logger warn, the operation failed with an exception, so I'll just log it. Alright, so if I run it this time, I should see something in the output. Yep, there it is. So that's my output. So now I know that even having to look in the browser, I know that I created a scenario with this ID and with this name, and I know it was a success. And again, if I go to the browser, refresh, I'll see it right there. Okay, let me delete it again. So that's cool. Obviously, there is more I can do. Not only do I want to create a scenario, I also want to fetch its blueprint and keep it in a variable so that I can use it later, possibly modify, or I don't know, whatever. It's my custom code. I might have ideas how to, work with blueprint. So in this case, I can say just then when you have your scenario, please do something else with it. Map it to some other object. So again, I can say make client, and this time get blueprint. Blueprint of the scenario I've just got created. And again, let's just log the operation. So actually I need to return this. Yeah, Java is so verbose compared to Kotlin, but let's see. On success, this time I'll work with a blueprint. So say logger info. The blueprint is, and then blueprint. Or on failure, I could do pretty much the same as before. logger warn failed to fetch the blueprint, and then throwable. All right, and possibly don't need this. Let me see more. Oh, probably do. Oh, I see. I don't need these brackets here. And then I don't need the return statement either. Well, it's a bit tedious, so let me just leave it as is. All right, cool. So let's run this. This time I should see two different outputs. First of all, I should see a log about a successfully created scenario, and secondly, I should see a log about a successfully created blueprint. So let me run that. I mean, not created blueprint, but successfully fetched blueprint. And yes, indeed, that's the case. So again, I can see the scenario was created just fine, and there is its blueprint. And if you check the scenario ID, the value actually matches the one that's of the script of the created scenario. All right. Double check in the browser that that's the case. Yeah, indeed, it was created again. Lastly, I just wanted to show that the output is stored can be stored in a variable, so it's a blueprint. Oh well, final blueprint, because this is Java, so there's some legacy stuff to be aware of, nothing major. Okay, so what happens here? Basically, initially I'm creating a scenario, and if I just extract this information, this call into separate call, as you can see, I will get something that's called result containing a scenario. Result is like a container that either contains the successfully created object, which in this case is a scenario, or it contains a failure. And I've designed the client in this way so that I have control over exceptions. I don't want my client just randomly throw exceptions, and then your own code then just is blown away by this unexpected exception. So I wanted to give you control over the processing. So as long as you work with as long as the resulting object is wrapped into the result, you don't need to worry about exceptions being randomly thrown from the client. It's only at the time where you want to fetch the actual created object, such as a scenario, you need to make a decision. So we can say either get or null. So in this case, you will receive a scenario. Which will either be a valid object, or it will be null in case of exceptions. Or you can say get or throw. In this case, the code throws an exception or returns a valid object. So a scenario will always be populated, but the downside is that your code then might throw an exception, and you might need to try catch it. So you might need to say something like try scenario catch exception X, and then you again are in control. Alright, so let me just turn into code to its previous state. Alright, so obviously, because I call this then method, which I borrowed the concept from JavaScript, from the promise construct. I just simply wanted to be able to chain these make client calls so that you can easily create workflows. So in this particular instance, my workflow comprises of 2 steps. In the first instance, I create a new scenario. In the second instance, I get its blueprint and then keep it in a variable. So now, having the resulting blueprint, I can just print it out, and we can have a look at how the blueprint actually looks like. So let me just clean the imports, and this time I will debug the main method. So it should hit this breakpoint here, and we can have a look at the final blueprint object. Compilation is taking a moment. Okay, now it's done. Alright, so as you can see, here is the final blueprint. That's the ultimate result of the entire operation. What it does, it represents the scenario's blueprint. So the name of the blueprint is this. It refers to this scenario, and obviously there is the raw JSON, which is not too interesting, but what it also contains is like it parses out it extracts all the modules from the blueprint and represents them using their identifier and a name. I plan on improving this further and display even the value that's kept in each of the modules. In my previous video, I showed you how you can modify the module's content, and to be able to do so, you need to know the ID of each of the modules within the scenario. So this does that. Alright, so as you can see, there are like 5 different modules. They each do different things. So this is like set in a variable. This here is the router, I believe, and this is our parse JSON component, and so on and so forth. So they all correspond to these modules here, just to make it super clear. So these would be my modules. There is actually not the router. Apologies. So this would be set variable. If I have a look here, that's the ID 5 set variable. Then there is compose a string. That's number 10. There's the string transformer. Number 9 is another string transformer here. And then there are 2 other modules. One composes string, the other one parses JSON, so it will be 12 and 13. Yeah. Another space for improvement here is that they could be ordered. That would probably help with you to see like where exactly they are in the scenario when you're reviewing the scenario in the browser. But okay, that's for later. Cool. That's all I wanted to say about the Java code. let me just contrast it with the code written in Kotlin. So Kotlin compared to Java is a bit more concise, but I also have here the main method that I can run. And compared to Java, it adds additional compile time safety. So let me just explain that. But first of all, let me just create a new client instance. So in a similar fashion, I'm just going to say make client. I just need to make sure I put it in the right package. EU, and then I pass the token. And this, I actually don't need a semicolon in the end. This would be my make client instance. And again, I want to create scenarios for things. So I can say make client, create scenario, pass in team ID, folder ID, and a blueprint path. But while the compiler isn't happy, it complains about suspend function. Well, with Kotlin there is this concept of asynchronous programming called coroutines. Coroutines, this is definitely a subject on its own. There's no time for me to explain them in this post, but you can look it up. There's plenty of tutorials and explanations on YouTube and elsewhere. It's a great feature, but it allows me to easily structure asynchronous code and work with it as if it was a blocking code. But I need to wrap it in a special block. Just to make it runnable. So this essentially turns it into a synchronous call and makes sure that it gets executed. All right. What I wanted to show you is this additional compile time safety. What I mean is, if folder ID and team ID were primitives, I could easily swap them. So if I go back to my Java code, in my Java code, I could by mistake do this, and the compiler would not warn me. So now this code is perfectly valid, but it's wrong. I swapped the team and folder ID, and as a result, the operation, the create scenario operation, will fail. Whereas in Kotlin, if I do that, the compiler will complain, because the team ID and folder ID are no longer primitives; they're objects. And I could have done the same in Java, except for I would get an additional overhead with creating these containers, team ID, folder ID. They would take space in memory in Java. But in Kotlin, there is something called a value class, which is like super efficient representation of a primitive value. So using a value class, this team ID wrapper or this folder ID wrapper won't take any space. And that's why I can safely use it without worrying about performance overhead, and I gain this additional benefit of compile time safety. All right, so, and then obviously I can do all the operations I was talking about previously. So just very quickly, I create a scenario. I can log success. In Kotlin, I can actually incorporate variables directly into my string literal, so I can just say successfully created a new scenario, and it is this one. The it object is, as you can see, my ID is helping here. it's a type of scenario, it's a scenario, so you can just print it like this. Or on failure, I can just say logger warn, and then again create scenario failed, throwable, or it. Okay. And then obviously I can combine it. So in this case, just make it explicit. I go to scenario, and then I can just say make client get blueprint scenario ID, and again log on success. Operation succeeded with it being the blueprint. At this point I probably want to be specific so that I don't confuse what's created where. So just create a variable blueprint and then just call it blueprint. Or log on failure, just say throwable, and then just say logger warn. All right. This entire thing would return a result. Well, result. The result is of type blueprint because I mapped the creative scenario onto get blueprint, and my ultimate resulting object is the scenario's blueprint. Again, if I want to just do the raw blueprint, I can just say get or throw, and that will behave exactly the same as I described before. So it will throw an exception or gets a successfully created blueprint. So I can just print line result. In this case, I can safely call it blueprint, and it won't complain. So again, if I run this whole block, alright, I got the new scenario and I was able to fetch his blueprint. Here it is, and here it is printed out again. So now I have the blueprint in a variable. There could be tons of other code working with this blueprint, making changes to it somehow, and then possibly using the make client again to update the scenario with the updated blueprint, and so on and so forth. All right, so just to conclude, today I showed you the client approach to modifying or maintaining your make scenarios remotely from within your code. I demonstrated JVM, two flavors of a JVM client, one written in Java, the other one written in Kotlin. The clients give you the benefit of having access to your local system, so you can, for example, store files locally, grab them by hand, format them nicely, don't need to worry about escaping. Kotlin, compared to Java, is more concise, has less code, even though it's not that much of a difference here, and gives you some nice additional features such as compile time safety compared to Java. So that's that. Thanks for watching thus far. Let me know your thoughts in the comment section below, and see you next time.